Welcome back. In this lecture, I am going to talk about the Python loops and iteration. So, let's begin. You might have already worked with looping statements in other programming languages. However, the Python loops are slightly different from what you would have seen earlier. Python allows you to create two types of loops: while loops and for loops. However, the for loops are further specialized for lists and commonly known as list comprehension. So, in this video, we are going to learn about three things: while loop, for loop, and list comprehension. Let me start with the while loop statement. I'll directly jump into an example to understand it better. So, we start with the keyword while, then we place a condition. You should also notice this colon. We used similar colon in the if statement as well, right? Finally, we place a block of statements from the next line. This block of statement is executed while the condition is true. In this example, the value of a is 0 and obviously it is less than 5. So, the condition satisfies and hence the statement block will execute. Inside the loop, we are printing the value of a and then incrementing it by 1. So, how many times are we going to print the value of a? 5 times, starting from 0 to 4, right? That's how the loop works in all other languages, isn't it? Python also allows you to use the break and continue statements. The break and continue are the same as they are in some other programming languages. You can use the break statement to break the loop even if the loop condition is not satisfied. Here is an example. This example creates an infinite loop. How? Well, we hard-coded the loop condition as true. So, no matter what, this condition remains true forever. And hence, the while loop becomes an infinite loop. Then we are checking a condition here and using the break statement to break the infinite loop. Similarly, the continue statement is to skip the current iteration and jump to the next iteration. Here is an example. So in this example, we start with num equal to 5 and run a loop while the num is greater than 0. We are also decrementing the num in each iteration to make sure that the loop doesn't run forever. However, when the num becomes 2, we want to skip the rest of the statement block using a continue statement. So this example is not going to print the 2. Great. However, you might have already learned that we should be avoiding the break and continue statements as a good programming practice. That's all about the while loops. The next type of iteration is the for loop. We use the for loop to iterate over a sequence such as list, tuple, range, and string. You can use the for loop to iterate over other iterable objects as well, such as set and dictionary. Here is an example of iterating over a list. We start with the keyword for, then we have a target variable. Finally, we have the sequence or any other iterable object. The loop will iterate over the iterable object, assigning one element to the target variable in each iteration. You can also use the break and continue statements in the for loop. However, I do not recommend using them anyway. I have been talking about the range sequence for a long time. However, we never used them. Let me introduce you to the range sequence. Python range sequence allows you to generate arithmetic progression. Let me show you an example. You can create a range by simply calling a range function. The range function takes at least one argument, and the single argument represents the stop counter. However, when you supply a single argument, the range function assumes a default start counter as 0. You can see it, right? My range is represented with two values. The first one is the starting value and the second one is the ending value. The range sequence is mostly used with the for loops. Let me create a simple for loop and show you. So, we are going to iterate through the range and print all the elements. Great. So now you can observe one more important thing. The ending value of the range is not included, right? The my range starts at 0 and stops at 9, just before 10. Instead of using the default start point, you can use any arbitrary starting point. Let me show you. The starting point is always inclusive and the end point is excluded, right? You can also give a step size as the third argument. Make sense? You can use a negative step size. Great. The final topic of this lecture is the list comprehension. We often need to create a new list by transforming an existing list. And this is a prevalent requirement. Let me show you a super simple example. Let's assume you have list of tuples. Each tuple pair represents a length and breadth of a rectangle. Now you want to transform this list like this. Each element is a multiplication of the length and the breadth, right? Or you can assume a little different list like this. In this new list, we preserve the length and breadth, but we also include the area, right? How will you do it? Here is a traditional approach using for loop. So we declare an empty list, loop through the existing list to calculate the area and append the result into the area list, right? You can also make the rectangle areas list using the same approach. Declare another empty list and add one more line in the loop to append the transformed values to rectangle areas, right? This is all fine and works well. However, Python offers you a shortcut method to do the same using a more concise code. And that is what we call list comprehension. Let me show you. So we have our rectangles. Now we want to create a rectangle areas list. So this is how you create an empty list. Now with this empty list itself, you can run a for loop like this. And prepend the transformation function like this. So we are running a for loop and getting a tuple in each iteration, right? And then we are applying this function on each tuple to return a newly transformed tuple. List comprehension uses a functional programming approach and takes a Python lambda. However, you can simply think of it as a simple function or expression. The result is another list. Make sense? This comprehension is more concise and heavily used in functional programming libraries such as PySpark. Great. That's all for this lecture. See you again. Keep learning and keep growing.